We're 3 days away now from a nor'easter, meeting up with some Arctic air, and bringing some more snow to New Jersey. Let's break it down. All right, so first thing I want to point out is that today, Bobby Martrich of EPAWA Weather, he laid out a great analysis of some research he did this morning. And he posted it on his social media pages. And I'm sure he's going to talk about it tonight in his nightly video that he does. So I highly recommend you check out their YouTube channel, visit their social sites. It's great analysis. And I'm going to try my best not to botch it here and just reiterate a little bit of what Bobby said, as well as a little bit of something to add on to it. The main principles is that we've been looking at two features here. You have the northern energy of the trough, and you have the southern stream energy. What Bobby pointed out is this little guy right here, which is currently over here, and this is on land. It's sampled better than energy out in the ocean, where there's less abundance of sensors and data collectors. This is on land. It's better sampled. And what this piece of energy does is it gets to about here in the southeast U.S. On Friday. And it's not even going to drop like precipitation or anything, but it is a little batch of energy. And what that does is it sets the thermal gradient boundary in its wake, so that when the southern energy and the northern energy do phase together, it sort of sets up where the surface coastal low forms here and where this upper low wants to close off. Because once this upper low closes off, it's going to want to pull the coastal low towards it. So for that reason, that energy has been setting that boundary down so that the low closes off way down here, and that's too far, to the southwest of where you need it to be to bring a strong snowstorm to all of New Jersey and into PA. And then the fourth piece that Bobby mentioned was this out here, which is called a kicker. Now, look, steering currents like to round even a little shortwave like this, but it provides west steering currents that boots the low out to sea. So that's why our low has kind of been forming like this, doing a retrograde loop as it's attracted to the upper low, but then it's quickly, exits stage right instead of coming up the coast. So where Bobby was going with all of this is that he does not think this can be pulled inland and give everybody on the other side of the I-95 corridor a big snowstorm. It sort of points out how if it is going to snow, most of the snow is likely going to stay around I-95 or to the southeast of it. Could it go northwest of 95? Maybe if the precipitation chill is a little bit bigger, if there's more extent. But as far as this impact on the low of the track, the track of the low, that's becoming more of a set thing here. And I'm going to pop up to a larger view here, and this is what I want to kind of add onto it. This trough is remaining positive for too long. Right, you have a positive trough axis. When you look, a couple days ago when there was a huge storm showing, you had a negative trough axis, right? But that is not now showing until you're at this point, which is too late, right? You get to here, the low's already gone, but there's no, it's out, it's kicked, and maybe it gets pulled into like Nova Scotia or Newfoundland or something like that, but it's too late for Jersey by the time it becomes negative. The main time for us, it's like this, so it's tilted slightly positive. So that's the other reason, I'd like to add on top of what Bobby said as to why this low can't really give everybody in northwest Jersey and most of eastern PA a strong snowstorm. So moving forward, that is the question now. If you eliminate that interior solution where like it got too warm at the Jersey Shore to even snow, right? That's no longer a thing. That's pretty much off the table at this point. So our furthest northwest extent is probably something like what the European ensembles are showing right now, which I'll get to. So does it bring snow to or just past I-95? Does it just graze the coast, which is becoming a more likely solution, or does it still miss out to sea? It's still very plausible of a solution for this to miss out to sea. So let's step down to some lower levels and look at some surface output here. Now this is the GFS, and I think a lot of these models are struggling here. You have like almost a Bermuda Triangle of lows here. Now there is a low. Let me step up a little bit higher. There is a low that wants to form out of the Bahamas. You see that one right here? That low gets going out of the Bahamas before the main storm coastal low forms here on the front of that trough. And once that forms, then that Bermuda low is out here. And it kind of, some of the models are doing almost like a Fujiwara effect of these coastal lows, which, I don't know if it makes sense right now. Is it possible? Sure. Is it probable? I don't know. You would think with a big trough like this, right, you'd have more of a singular low that rides up the coast. But the evolution of this Bahama low forming is something that popped up on all guidance today. So it's something we're going to be watching as we head into closer to the storm system. But let me step back down just to show you the GFS output. So there's the low here. You'll see it come back and do the little loop there. See that? It takes a step back and retrogrades. And that's what's absolutely nailing North Carolina. This storm starts in South Carolina late Saturday night. And then, overnight it's nailing North Carolina and much of eastern Virginia, lower Delmarva Peninsula. That's what most models are targeting now for the craziest part of this storm. But then afterwards, the question is how far does it get up into New Jersey, right? Now, even still here, I don't like this precipitation shield. When you look at a precipitation shield, you typically have more of a solid shield where this is all blue and this is all light blue, right? Heavy snow and light snow, which would be a graze of a hit. But given how these lows, want to impact each other, right? They're all sort of pulling at each other. It could disrupt the shield like that. But, typically you'd see a more of a complete precipitation shield. So the GFS is back to being the most southeast solution, which is where it typically belongs, according to its biases, to keep systems too far to the southeast. The Canadian's a little bit more interesting for coastal Jersey interests. Again, look at this like Fujiwara. This low dances around this low, and then they eventually do a little tango there, a little bit of coastal low pressure tango there, right? But it's bringing the shield in more into southeast Jersey, I-95 and southeast. And if we look at snow output, step down to the mid-Atlantic, and we'll go to winter chair output because it can be very, very cold. I mean, this is dropping almost 10 inches of snow, the Canadian, up and down Monmouth County down to Cape May County. But look how quick it cuts off as you approach 95. It goes to nothing by the time you step over the Jersey Turnpike, basically. Gets a little bit of light snow up in northeast Jersey, a little bit in southwest. But for the most part, the Canadian's focusing, it's targeting southeast Jersey. Step over to the Euro, which has ticked back to the northwest. Again, you have this low pressure dance here out in the ocean, from that low that formed in the Bahama to the main low that storms on the main storm that forms on the front of that trough. And it just, I don't know, it's very strange to me. I don't think this is how it's going to look 1 or 2 days from now. So more changes, yay. But yes, the European does graze Jersey. And if we step down and look at the precipitation shield and how much snow that drops, again, heavily focused on the coast. Sharp cutoff right to the northwest of I-95. You get a little light snow into like southeast PA and up into northern Jersey, but that's really light amounts, coating to an inch at most. So you have the Canadian, you have the European heavily targeting the the Jersey coast, really, with the heaviest amounts. Now the European ensembles, and remember, ensembles are multiple runs. The models run like 51 different times, I think, for the European, with slightly different algorithms and starting conditions. And what it does is it generates 51 different solutions. And what you do is then take a mean average of all of these, which puts the center of that right here, right? But look at all these solutions on the left side of that. Those are all locations that the low could end up. If that ensemble member were to verify, that'd be one heck of a surprise for everybody here. But you take the average. If you take a visual average mean, you can then generate a estimated. Let's see here. Estimated precipitation shield based on the mean average. And look at that. That's even further than the operational run. Normally, when the ensembles are further than the operational run, it usually indicates that the next operational run is going to take another tick in that direction. So I'll be looking at the euro to see if the euro moves a little west tonight. But this is getting all the way into, that's crossing the Delaware. That's getting up into North Jersey. Now, ensemble means don't factor in snow ratios. They just output their winter output at 10 to 1. And we know this is not going to be 10 to 1 snow ratios because we're in an Arctic air mass right now, and it's going to stay cold right through the storm. Any snowfall that happens this Saturday night through Sunday is going to happen in weather temperatures in the teens, maybe lower 20s at most. So 15 to 20 to 1 snow ratios are in play, just like this past weekend. Apply that to these 7 and 8 inch outputs, and you're up close to a foot here on the coast. So again, targeting the coast. But what the European ensembles does do is bring a little bit more of a light to significant hit up and down the I-95 corridor with still a very sharp cutoff, maybe out to Allentown, PA, up north of 78, maybe to the northwest of 287. I know that doesn't form a straight line that's parallel to this axis, but just a reference points of where the noteworthy snow would make it to, something that's possibly a little plowable. But yeah, so everything's kind of ticking northwest. It ticks southeast in the morning. It ticks northwest in the afternoon. It ticks southeast in the evening, and then here we are ticking back to the west. So you get that windshield wiper effect. The energy passes over more abundant zones of sensors, and then it passes into areas where there's less abundant amounts of sensors. So that can affect it. That can affect that windshield washer effect as the data goes through the algorithm, compares against the past 30 years of climatology, and then predicts what it thinks it sees. So I think we're gonna be narrowing in tomorrow, on a general idea. But we're still not anywhere close to making a snow map with amounts, especially for this coastal area, because it's such a volatile environment. It could really go one of a few ways. Today we're just one step closer, basically just reiterating everything that we put out in the article earlier today. But I do want to talk about the coastal flooding element here. Now, what you're looking at here is tidal guidance, tidal model guidance from Stevens Tech, and this is Sandy Hook. And the way that this works is the peaks here are high tides, the pits are low tides. And we're looking at mean lower level water, which is like the average low tide of recent I don't know if it's a couple days or a couple weeks, but it's the average low tide, how many feet above the average low tide it's going to get. So you're pretty normal here until you get to Sunday. Now Sunday, this is between about 6 and 9. We'll call this about 8 a.m.-ish. Okay, you might want to check your tide levels because it's slightly different up and down the coast. But we'll just say 8 a.m. give or take an hour, right? That's going to be the first high tide of concern on Sunday morning, and I'll show you why. And there's another one that's a little bit less, which occurs Sunday night, but Sunday morning is going to be the main one. So the yellow across here is minor flooding. This orange, I think it's orange. I'm horribly colorblind, but it looks orange to me. And then like a dark pink or purple up here. That's basically minor, moderate, and major stage flooding, right? So the purple line here is the average of the ensembles, tidal guidance ensembles, and then the gray area is the uncertainty. So it could go as high as this. Maybe there's like a 5% chance of it going that high, and there's a 95% chance of it being in the middle. So that's sort of the spread there. So this is Sandy Hook, further up the coast, where it'll be subject to less winds, especially if they're getting kind of blocked by Long Island, right? So only minor flooding is predicted for the Sandy Hook tidal guidance area. Let's go down to the Barnegat Bay. Barnegat Bay, you'll notice it's into the moderate level, and it could easily reach major. So it's going to be a little bit more, as you get further down the coast. If we go down to, what's the furthest south I can go? Seacon, Atlantic City, Ocean City. We'll do Ocean City. Ocean City is like the high end of minor, but it has the potential for major. So, look, there's a few things happening here. This is the European wind gust guidance. So this is midnight, Friday night, right? Starting Saturday morning. Wind gust in miles per hour that you're seeing. So the low is just approaching here. It's still down. When this starts, you're going to have some winds start to build out of maybe the east-southeast, right? On the northern side of this low, you have high pressure spinning up this way. You have low pressure spinning here. So it's going to start that wind direction out of the east-northeast. Then, once we get to later Saturday night, overnight, now you have higher wind values. Now you're approaching wind gusts of 40, 45 miles an hour on the coast there. But your wind direction is more like this, right? Because ultimately it's trying to feed down into this low. So you have winds coming out of the east northeast, right? And the inlets of Jersey, they run like this, right? So it's not exactly parallel to the inlets. It's more against them, against the grain. Still pushes water in, but not as much as if the wind was straight out of the southeast, right? So let's erase this and rock a little bit further in time. We'll go out to later Sunday morning. So Sunday morning, this is the strongest winds. Now you're getting up near 50 miles an hour. And the winds are going to be more like this. It's still considered onshore, but it's more at an angle, more of like a northeast angle. And this is why it's it's a nor'easter, really. You have a retrograding stalled low here, and you're going to have a period of 12 hours or more of onshore flow. So that's the criteria for me for a nor'easter. And then you have the general swell that radiates, from the storm itself. And large waves will be pushing this way, the wind will be pushing this way, and that's why Sunday morning looks like the highest tide of concern. Now we do have some positive and negatives. The positive would be the strongest winds they're not parallel to the coast. Another positive would be we don't have a lot of heavy rainfall that's draining into estuaries and back bays. That's going to have nowhere to drain and increase the flooding, right? Any precipitation that falls is going to be snow, and it's not going to drain into the back bays and creeks. It's just going to stay on the ground. So we don't have that element. So that and the wind are positives. The negatives is we do have a big storm, possibly a sub 980 millibar low, and we also have a full moon on Sunday. So with that greatest high tide Sunday morning, we have a full moon. And that's why I think we're seeing some of the flooding guidance get into the moderate predicted stage, because you have the astronomical tide to begin with, which is higher than normal from the full moon, and then you factor the storm surge on top of that, and that gives you that total level over mean lower level water that's going to be up and down the coast. So, look out for some coastal flooding. Um, Sunday, mostly Sunday. Looks like we're all right Saturday, but Sunday is when it starts, specifically that 8 a.m. period Sunday morning. So, we're not just watching for snow here. This is going to batter the coast pretty good. There's going to be some ripping winds along the coast. Lesser winds once you get away from the ocean for here. Notice it, when it's 50 gusts plus here, it's only like 30 away from the ocean. So it's really gonna crank hardest along the ocean facing areas of Monmouth down through Sandy Hook. You'll have some water coming into the Delaware Bay, so elevated waters here, but not so much as the ocean facing coast who will take it to the face basically. So bottom line is we're monitoring data and live observations tonight through tomorrow morning. What we hope to do is get a map out tomorrow that will not feature expected snow amounts, but just general ideas. What areas will see the most amount of coastal flooding. We'll outline that along the coast. Maybe the areas where we believe it could snow the hardest, so we might circle an area here to the southeast of 95. Maybe we just say that light snow makes it to like here, somewhere around here. Just a general ideas map is where we're going to be at tomorrow. And then on Friday, we'll issue a first call, which will have a snow map with amounts, if warranted. If we're still looking at snow amounts on Friday, we'll issue a snow map with amounts. And then that gives us Saturday to update that map heading into the actual event. And then live observations will begin Saturday night, and we'll roll from there. So yeah, windshield wiper effect back and forth, but snow's still targeting at least the southeast Jersey coast, possibly a little bit further inland than that. I'm Jonathan Carr. Have a great night, and please be safe.